Okay, so this is your study guide for Unit 1 and 2 assessment. These 7 categories are what's going to be on your test, just a couple questions each. If you want, you can pause and read those categories, but we're going to go through them one at a time. Okay, so our first category is determining rational and irrational numbers. So rational numbers include fractions, repeating, and terminating decimals. So I don't know why I wrote all this out, but now you know. So what I mean by that is like fractions, obviously. And then repeating decimals, we know are decimals that go on forever. But the difference between a rational number that goes on forever and an irrational number that goes on forever is we know what our we know what our rational number is going to look like. It's rational, it makes sense. And then terminating decimals are just when you think of decimal. Just that's terminating decimal. Whereas we have irrational, they're crazy. We never know what they're going to do. It goes on and on and on forever, and we don't know what it looks like. Anything that just goes on all crazy. One thing I forgot to mention for rational is pi is also rational. All right, answer this question on your Edpuzzle. Okay, hopefully you put C because yes, C is irrational because it goes on and on forever. It doesn't follow a pattern. We don't know what it looks like. It's just crazy. This is just regular terminating decimal. This is just a really big number. I wish that was in my bank account. And then D, it does go on forever, but we know what it looks like. Fractions into repeating decimals. So for example, if I had 2/6, I would put my top dog in the doghouse. I call this my doghouse. My top dog is my top number. I put it in my doghouse. I ask myself, how many times 6 go into 2? It doesn't. If I list my multiples of 2, or of 6, I will never get 2 because it's too big. So I'm not going to keep going. I know it doesn't go in. 6 goes into 20, though, but you have to have your decimal 3 times. 1, 2, 3. So I'm going to put my 3 up top, which is 3 times 6 is 18. I'm left with 2 again. Well, let's bring down another 0. 6 goes into 20. Oh, 3 times again. Those of you that have been paying attention during warm-ups, because you're probably sick of me being like, oh my gosh, it keeps going. But yes, it's going to keep going. And so when you get to a point and you're like, okay, I'm just going to keep getting 2s left over, then we know it's repeating. So the way I would write this, you can do ... but the most proper way to write it is with a line over whatever's repeating. All right. Answer this next. Why is it doing that? Next slide on your Edpuzzle. Do your work in your notebook. Okay, hopefully you also got 0.3 repeating, because again, our 1 would go in the doghouse and then be really the same thing as the last one I just went over, but instead of, here, let me draw it out. So 1/3 is a fraction. We need top dog in the doghouse, 3. 3 doesn't go into 1, but it goes into 10. Don't forget your decimal. 3 times, I get 1 again, which is 10 again, which is 3 times again. So really the same thing as the last one. And so we end up with 0.3 repeating. Add, subtract, multiply, and divide rational numbers. Again, this is from the warm-up. So the most important thing to know about adding is if we go opposite directions, we subtract. When we go same direction, we add. And actually, that's the same with subtracting, because any subtraction problem, just think of it as a negative number. So what I mean by that is -8 minus 2. Well, I can think of this as -8 plus -2. Well, now I know I'm going the same direction because I go back 8, back 2, and I get -10. If I go opposite direction, so for example, I should have made this separate slide. That's okay. If it was -8 plus 2, +2, Then I would go back 8, forward 2. Now I'm going opposite directions, which means I need to subtract. Just because it says add in between here, we're not actually adding, we're subtracting. So I get 6, and it's going to be -6 because I had more negatives than I had positives. And then last thing about adding and subtracting, so let's say it's 8 minus -2. Well, this is the opposite of an opposite, which is +2. So this would just become 8 plus 2, which is +10. And then you guys did really well with multiplying and dividing rational numbers. I'm not too worried about that. But remember, if you love to hate, then you hate. If you love hating, you're a hater. If you, let's see, hate to love, you're also a hater. If you love love, I'm not going to write this one down because that's easy. If you love love, you're a lover. But what if you hate hate? That means that you hate hate. You wish it didn't exist. So you are a lover. Okay, which again, this is for multiplying and dividing, which you guys did really well on. All right, answer this. Next slide. There will be 4 different questions for this next slide, but they should all go pretty quick. Answer number 1, answer number 2, answer number 3, answer number 4. All right, let's go over them. Sorry, and I am going kind of fast. You can always rewatch, pause, anything. So on this one, we're going the same direction. I go back 9, back 8. That means I add, even though it says subtract. 9 plus 8 is 17, and I know it's going to be negative since I went backwards. -7 plus 8, that means I go back 7, forward 8. So I'm going a little bit more forward than I am backwards, and I'm going opposite direction. So I'm going to take my bigger absolute value, put it on top, 8 minus 7. That gives me 1. Now, how do we figure out if it's positive or negative? I only have 7 negatives, but I have 8 positives, so it's +1. On number 3, you hate to hate, which means you love, so it's going to be positive. 3 times 8 is 24. +24. And then number 4, you hate to love, a negative divided by a positive is hate. And 25 divided by 5 is 5. So you get -5. If you got all 4 of those correct, good job. If not, hopefully. And again, this looks exactly like your warm-up. Just usually I make this one via repeating decimal. Other than that, this is the warm-up we've been doing the past couple weeks. Unit rates. Okay, so this is all about per means 1. So if they say per dollar, per mile, per anything, then that means 1. Okay, so we've gone over this. This is pretty recent, so I'm not going to talk about it too much. But you just take, if we know how much one thing costs, we can figure out the price of anything else, and vice versa. If we know that 6 candy bars cost $24, we can figure out, here, let's do that example. If I know that 6 candy bars, cost $24, I can figure out how much is 1 candy bar by setting up a proportion. I'd say, okay, well, how do I get from 6 to 1? Well, I would divide by 6. So how do I get from 24 to x? Divide by 6. 24 divided by 6 is 4. So that means each candy bar is $4, which those are some gourmet candy bars because that's expensive. All right, answer this one in your head puzzle. Okay, so let's see. 4 pens cost $16. And it doesn't really matter which one you put on top as long as dollars and pens stay the same. So how much did she pay per pen? So how much money, X amount of money, for 1 pen? Well, let's see. In order to get from 4 to 1, we divide by 4. So in order to get from 16 to x, we also divide by 4. 16 divided by 4 is 4. So again, $4. I wasn't very creative with these numbers, huh? But that's okay. It's all about the concept. Determining a proportional relationship or the concept of proportionality. So things you need to remember on here, because y'all kind of drive me nuts with this, because you guys acted like this was hard. So you're given a graph with X and Y. It won't always say X and Y. It might say dogs and dog food. It doesn't matter. And then our constant proportionality is Y over X. So you just divide, like if this is 1 and this is 3, then that means the constant proportionality is 1/3, just Y over X. And remember, we know if it's proportional if all the way down Y over X is the same. So if we, I'm trying to think. So 3/9. We know that that's going to have a constant proportionality of 1/3 because 3 over 9 is 1/3. It simplifies down to it. Same with, we'll do 30/90ths just because that's an easy one. This simplifies down to 1/3 as well. So that means that yes, this table is proportional. If when you do this in your Y and X, you get something different every time, then that means it's not proportional. And the way we write our constant proportionality as an equation is Y equals KX. So your Y and X will always stay the same. The only thing that'll change is your K, which is your constant proportionality. So in this case, it'll be Y equals 1/3 X, because that's my Y over X. Don't let all the letters confuse you. Most of the letters we don't even use. They just stay the same. All right, so first answer in your ed puzzle is the relationship between X and Y proportional. Next, what is the concept of proportionality? Okay, so hopefully you got 5 because 25 divided by, or is the relationship proportional? Yes, because 25 divided by 5 is 5, 30 divided by 6, 5, 35 divided by 7, 5, 40 divided by 8, 5. Cool. So what's our constant proportionality? 5. An even better answer would be Y equals 5x. But also be careful because on the math Excel part of your test or like on the online part of your test, be careful. They might just want you to type in a number. So make sure you read. If they just want the constant proportionality, like then they might just want 5. If they want the equation for the constant proportionality, then they want this. Answer. Oh wait, never mind. You did already answer that. Graph proportional relationships. Okay, so this one is kind of hard to explain with no graph. But basically, the constant proportionality, first, a graph is proportional if it goes through the origin. Write this down if you don't have it somewhere, which you should, which is the point 0, 0. And it's proportional if it's a straight line. Okay, so if it, and this is Ed Puzzle 2.5. I know a lot of people didn't watch that, and this is the concept I was absent that day. So basically, like this, actually, that's not even a good example. So this one actually isn't proportional because it doesn't go through the origin. But it is a straight line. Oh gosh, I stink at drawing. I feel like every teacher says I'm no artist. Okay, that was awful. But anyway, pretend that's line straight, and it's gonna go straight through the origin. That's proportional. This is not proportional because it's not a straight line, even though it cuts through the origin. Okay, so this, they straight up say this one is proportional. So you need to figure out what's the concept of proportionality. Answer in your ed puzzle. Okay, so the concept of proportionality on our graph is wherever it crosses 1, okay, on the x-axis. Whatever the y is, that's our concept of proportionality. Because remember, it's y over x, rise over run. So on this one, we don't have 1 on our x-axis, but we can see if this is 2, then halfway between it must be 1. Okay? So we go rise, run. So what is the y coordinate that corresponds with that? Well, it's 12 because, again, there's no 12 on here, but halfway between 0 and 24 is 12. So then it says write your answer as y equals k, where k is your constant proportionality. So I know that sounds fancy, but basically it's just y equals 12x. Boom. Okay, and that makes sense because let's look at 24 and 2. Well, y over x, 24 over 2 is 12. Boom. Okay, I could do the same thing for 4, 48. 48 divided by 4 is 12. 72 divided by 6 is 12. 96 divided by 8 is 12. Almost done, y'all. Ooh, last one. Solve problems using proportional relationships. So on this, you need to find your constant of proportionality, your k, and then set it equal to whatever you're trying to find. So here, I shouldn't have wrote k. So what I mean by that is, like, if you know your constant of proportionality is 12, meaning 12 miles per hour, okay, per 1 hour. So this is our constant of proportionality. And then set it equal to what you're trying to find. So if you're like, okay, this lady went 12 miles per hour, how many miles did she go in 4 hours? And then we would just say, okay, well, to get from 1 to 4, we multiply by 4. To get from 12 to x, we also need to multiply by 4, which is 48. Well, let's see, 12 times 2 is 20. Yep, 48 miles. Okay, so just setting up proportions, which again, we've been working a lot on with unit rates and this and that. Just now we're finding, sometimes you have to find your constant of proportionality, which again is just y over x. So try this next one. Okay, so let's talk about it. So on this one, they don't straight up say, here's your constant proportionality. Like if they would have given us 1 and then whatever our y is, then they would have told us our constant proportionality. But in this one, we need to find it. So let's do 220 our y over x, which is 20. And we only need to do one of them because they're all going to be the same, right? Because it says it's proportional. So 220 divided by 20 is 11. So what that means, because this is 220 calories over minutes. So that means she burns 11 calories in 1 minute. That's our constant of proportionality. They want to know, well, how many calories, x calories, will she burn in 29 minutes? So in order to get from 1 to 29, I multiply by 29. In order to get from 11 to what I'm trying to find, x, I also multiply by 29. And 11 times 29, 329, no, 319, 319 calories. And again, we could look at our table and see if that makes sense, because 29 minutes would be like right here, almost to 30, and 319 calories is again almost to 330. So yeah, that makes sense. So if you got something like 500, well, we know that wouldn't make sense because in 29 minutes, she couldn't have burned 500 calories because in 40 minutes, she only burned 440. So just using that logical reason. Okay, your test is third bell, yours is Thursday, and what is it? Fourth and sixth bell, yours is Friday. Sorry, brain fart. All right, thanks for watching. Goodbye.